Okay, we are doing Chapter 2 quadratic review for the Chapter 2 test. First set of questions, numbers 1 through 5, write a rule for G, described by the transformation, then identify the vertex. We're not going to ask you to FOIL on these ones. So number 1, f of x equals x squared plus 3. We're going to do a horizontal stretch by a factor of 5. Then followed by a reflection in the y-axis, followed by a vertical translation down 4. We need to do them in the order that it's told to us on this paper. We don't follow the describing order because we're performing this on the graph, and then we're going to do the next one and then the next one. And if we don't follow that order, we get something different. So horizontal stretch by a factor of 5. Remember, everything horizontal is inside, and it's reciprocal when it's horizontal, shrink and stretch. So that horizontal stretch by a factor of 5 looks like f of 1/5 x. And when I plug that in, I am replacing the x with 1/5 x. So 1/5 x squared plus 3. Then I can perform the square. 1/5 x, square 1, 1, square 5, 25, x squared plus 3. The x still has a square on it. I don't know what x squared is, so I have to keep that square there. It goes away off of the 125 because I did the square. Next, the reflection in the y-axis. Y-axis reflection is f of negative x. The negative is inside. So that's 1/25 times negative x squared plus 3. Now, because this parabola its axis of symmetry is the y-axis, the square cancels that negative, right? Negative x squared is negative x times negative x, which becomes a positive x. And I end up with 1/25 x squared plus 3. It's centered right now on the axis. It's actually positive 3. And so if I rotate it around the y-axis, it's not going to look any different. And then the last one is a vertical translation down 4. That's f of x minus 4. Vertical translations happen outside, right? So I take the whole function, 1/25 x squared plus 3, and then I'm subtracting the 4. So my final answer, g of x, is 1/25 x squared minus 1. Number 2, my function f of x is x squared minus 4. We're going to do a vertical stretch by a factor of 3. Vertical is outside. A reflection in the x-axis, also outside, and a horizontal translation left 3, horizontal's inside. So the vertical stretch by a factor of 3 is 3 times f of x. That means I'm going to multiply the whole function, x squared minus 4, by the 3. I need to make sure to distribute my 3. 3x squared minus 12. Then I have a reflection in the the x-axis, which is negative f of x. We multiply the whole function by a negative, 3x squared minus 12. Remembering to distribute the negative to the 3 and the negative 12. So this becomes negative 3x squared plus 12. And a horizontal translation left 3, that's f of x. Remember, everything horizontal is opposite. We want left to be negative, but it's plus 3, which means I'm replacing the x with my x plus 3, squared plus 12. So I should be creating a set of parentheses there with a square on it, and this is where we said we don't need to FOIL on this worksheet. So my final answer, g of x, is negative 3 times x plus 3 squared plus 12. Number 3. A horizontal shrink by a factor of 1/3. My f of x is x squared minus 1. Then we're going to do a reflection in the x-axis. And then we will do a translation right 4. So horizontal shrink again is inside, and it's reciprocal. The reciprocal of 1/3 is 3. So f of 3x. I'm going to replace the x with 3x. So 3x in parentheses squared minus 1. And then I will do the square. 3x squared is 3x times 3x, which is 9x squared minus 1. Next, we will do a reflection in the x-axis, negative f of x. Reflection in the x-axis multiplies the whole equation by a negative. So negative times 9x squared minus 1. Remember to distribute to the 9 and to the 1. So I get negative 9x squared plus 1. And then a translation right 4. Translations right and left are inside. Right is minus 4. We want it to be plus, but it's not. It's opposite. And so I'm going to replace the x with what I have here in the parentheses. Negative 9 times x minus 4 squared minus 1. We're not just subtracting 4 from some part in the equation. We're replacing the x with x minus 4. So my final answer, g of x, is negative 9 times the quantity of x minus 4 squared minus 1. Number 4. We have f of x equals 8x squared plus 1. We are first going to do a vertical translation up 7, followed by a reflection in the y-axis, followed by a vertical shrink of 1/2. So I'm going to start by a vertical translation up 7. That's f of x plus 7 on the outside. So that takes 8x squared plus 1 and adds 7 to the outside, which gives me 8x squared plus 8. My next instruction is to reflect it in the y-axis. So that's f of negative x. So I'm replacing x with negative x. Plus 8. Negative x squared is negative x times negative x, which is just positive x squared. So I have 8x squared again, plus 8. But we want to see that work on your paper. We're looking to see if you understand what you're doing. So just leaving it is not enough. You got to show your work. And then lastly is a vertical shrink of 1/2. That's 1/2 times f of x, which means I'm going to multiply the whole equation, 8x squared plus 8, by 1/2. And I have to remember I need to distribute vertical shrinks and stretches and reflections in the x-axis. So that's 4x squared plus 4 is my new g of x. Come on. So number 5, let's put that there. Reflection in the x-axis. So that's going to happen first with a horizontal stretch by a factor of 4, followed by a translation left 2. So I start with x squared minus 5. The first is negative f of x. Reflection in the x-axis. That's a vertical reflection. That's outside. Negative times the whole function, x squared minus 5. Going to distribute the negative. Negative x squared plus 5. Then a horizontal stretch by a factor of 4. Horizontal's inside, reciprocal of the number, so that's f of 1/4 x. So I replace the x with 1/4 x squared plus 5. When I'm squaring a fraction, I square the numerator and I square the denominator. The negative is outside, so it's not getting 1/16 x squared plus 5. And then followed by a translation left 2. That's a horizontal translation. It's inside. X plus 2 is inside the parentheses. So that's replacing the x with x plus 2. And don't forget the square on there. And then I don't need to FOIL that out. So my final answer, g of x, is negative 1/16 x plus 2 squared plus 5. Number 6, write the equation of the parabola that passes through 6, 4 and has a vertex of negative 2, 3. So vertex means vertex form. Y equals a times x minus h squared plus k. I'm going to plug in h and k. Then I'm going to plug in x and y. Okay, my h, let's use a highlighter here, is negative 2. The vertex of negative 2, 3. My k is 3. My x is the 6, x comma y, and my y is 4. So I'm going to plug it in first with just h and k. X minus negative 2 squared plus 3. That becomes y equals a times x plus 2 squared plus 3. Now I'm going to plug in my x and my y. My y is 4. 4 equals a times 6 plus 2 squared plus 3. Now I can simplify the parentheses. 4 equals a times 8 squared plus 3. 4 equals 8 squared is 64. 64a plus 3. I'm always going to write the 64 in front. And then minus 3. 1 equals 64a. Divided by 64. A is 1/64. So then I can come back here and write my equation. Y equals 1/64 times x plus 2 squared plus 3. That's my final answer. Okay, let's look at number 7. Write an equation of the parabola that has x-intercepts. X-intercepts, so we're going to use intercept form. Y equals a times x minus p times x minus q. Well, my p and q are my intercepts. P and q. It doesn't really matter. Q or p is 6, q is 10. Which way I put those two. But I have to make sure I'm not putting them in as x and y. My x and y are, well, let me fix my colors here. Because I did h and k in these colors. So let's do blue and pink, just like we did with h and k, and then red and purple. So again, this is y, and 11 is the x. Okay. Just trying to stay consistent with my colors to not confuse you. So we are going y equals a times x minus 10 times x minus 6. If they were negative, it would be minus the negative, which makes it plus. And then we can plug in y is 8 equals a times 11 minus 10 times 11 minus 6. So 8 equals a times 1 times 5. 8 equals 5a divided by 5. and A is 8/5. Then I can use this equation, y equals 8/5, x minus 10, x minus 6, to write my equation. So that was number 7. We're going to cut this off here, bring it down for us. So write an equation of a parabola that passes through -3, 10, and has a vertex. So we're back to using vertex form. A times x minus h squared plus k, or hk. And we're going to plug in x and y. So what are my hk and x and y? My hk is my vertex, so 3, -8. My xy is the point, -3, -10. So y equals a times x minus 3 squared minus 8. Now minus 3 and, minus 8. Okay, and then I can plug in my y. -10 equals a times -3 minus 3 squared minus 8. And now we'll simplify. -10 equals a times -6 squared minus 8. That's 36a minus 8. Add 8 to both sides. -2 equals 36a. Divide by 36. And -1/18, to simplify your fraction, divide them both by 2, is a. So I can go back to my original equation here. Y equals -1/18 times x minus 3 squared minus 8. Number 9, write the equation of the parabola. So we have the parabola. We maybe can find the vertex, but we can also find these x-intercepts. So we have -2 here and -10. And then we have this point up here, which is going to be -8, comma, the y is 2, 4, 6, comma 6. Okay, so we can find that information from the graph. Identify the point, identify what you know. I know the intercepts for sure, so I'm going to use intercept form. Y equals a times x minus p times x minus q. So I like to plug in p and q first. X minus -10. Oops, my blue point is -2. Again, it doesn't really matter. And x minus -10. So that becomes y equals a times x plus 2 and x plus 10. Now I can plug in my x and my y. Y is 6 equals a times -8 plus 2 times -8 plus 10. And so we get 6 equals a times -8 plus 2 is -6. -8 plus 10 is 2. -6 times 2, remember I'm multiplying, is -12a equals 6. Divide by -12. And a is -1/2. Make sure you reduce your fractions. So my answer, y equals -1/2 times x plus 2 times x plus 10. I'm using this equation to write it. Okay, number 10 asks to graph. Find the vertex, axis symmetry, domain of range, where x is increasing and decreasing. So number 10 is f of x equals -x squared plus 2x minus 3. So we have the 3 forms: standard form, vertex form, intercept form. You have to recognize them so you know how to get the information you need. This is standard form when I have the x squared and an x term. So my vertex, -b over 2 times a. So I get x equals negative 2 over 2 times negative 1. Remember, this is b, and this is a, negative 1. So that gives me negative 2 over negative 2, which equals 1. Now I can make my table. I put 1 in the middle. I pick 2 points to either side, 0, negative 1. Now if you're Mrs. Whip's class, you only did a table with these points. In my class, I make the rest of the table, and then we reflect it in the table. So what point do I know for sure when I look at the graph is that 0 is equal to negative 3. That's the one thing I can get from this equation, is my y-intercept just by looking at it. It's negative 3, so 0, negative 3. It is not the number, the y that goes with 1. I have to plug 1 in. So we're going to plug in x equals 1 to find the y value of the vertex. So that's negative 1 squared plus 2 times 1 minus 3. Negative 1 plus 2 minus 3. 1 minus 3 is negative 2. So my vertex is 1, negative 2. Then I can plug in negative 1. Negative 1. Negative 1 squared plus 2 times negative 1 minus 3. That's negative 1. Negative 1 squared is 1. Minus 2 minus 3. That's negative 3 minus 3, negative 6. Okay, so I can reflect those into the other part of the table. I can also reflect them when I put it on the graph. So that's what I want to show you. My kids especially. My vertex here, I'm going to put it in blue, is at 1, positive 1, negative 2. Okay, then I have the point here, 0, negative 3, that's my y-intercept. And then I have the point negative 1, negative 6. Well, since my axis of symmetry is the equation x equals 1, I can take these points and just reflect them to the other side of my axis of symmetry. 2 away from the axis of symmetry, 2 away from the axis of symmetry. It's the same thing we'd get if we put them into our table. Negative 2, negative 3 is that point, and then 3, negative 6 is the reflection of that point. And then we connect it. Okay, so again, our vertex is 1, negative 2. Our axis of symmetry is x equals 1. It's always an equation, not just 1. It's x equals 1. My domain is x contained in the set of all real numbers. My range, y, is less than or equal to negative 2. It opens down. The maximum of my graph is at negative 2, and everything is below it, so my range is y is less than or equal to negative 2. Where is it increasing and decreasing? Well, I read the graph from left to right, so it's increasing to the left of x equals 1, or just 1, but we always look at that axis of symmetry. It's increasing to the left of the axis of symmetry 1, and it's decreasing to the right of 1, x equals 1. All right, so number 11, y equals negative 1/2 times x minus 4 times x plus 2. This is an intercept form where we have it factored out. We don't see a square anywhere either. So my x-intercepts are 4, 0, and negative 2, 0. The x-intercepts come from what makes the inside parentheses 0. So really we're solving this equation. X plus 2 equals 0. And then my vertex is halfway between them. 4 plus negative 2 divided by 2, which is 2 divided by 2 equals 1. So y equals negative 1/2 times 1 minus 4 times 1 plus 2. And that's negative 1/2 times negative 3 times 3, which is negative 1/2 times negative 9, positive 9/2, which equals 4.5. So then we'll put that on a graph. On this one, I don't need to make a table, even though you might see a table on the paper. You can put these 3 points on the table. 1, 4.5, 4, 0, and -2, 0. So there's your -2, 0. There's your 4, 0. And at 1, 4.5 is my vertex. And I connect it. So my vertex, 1, 4.5, my axis of symmetry equation, x equals 1, the x value of my vertex. My domain is x such that x is contained in the set of all real numbers. My range is y such that y is less than or equal to my maximum, 4.5. And then let's look at the graph. We read it right to left again, so it's increasing to the right. Sorry, that's the left of 1, and then it's decreasing on the right. So decreasing to the right of 1, or x equals 1. Either one's fine. Number 12 is f of x equals 2 times x minus 3 squared plus 1. This is our vertex form. So my vertex is hk. So my vertex is 3, 1. I'll make a table with 3, 1 in the middle. 2, 1, 4, 5. And if I plug my numbers in, I get 2 times 1 minus 3 squared plus 1. 2 times -2 squared plus 1. Exponents first, so 2 times 4 plus 1, which is 9. Then I can plug in 2. 2 times 2 minus 3 squared plus 1. 2 times -1 squared plus 1. 2 times 1 plus 1 is 3. So I get 1, 3, and 9. I can reflect that in my table, or I can leave them out of my table and reflect it when I put it on the graph. So I can cover that work up. So let's see, our vertex is at 3, 1. My next point is 2, 3, and then 1, 9. Remember, there's my axis of symmetry that goes through the vertex. And that equation is x equals 3. The vertex is 3, 1, and I can reflect these points on the other side. That's what I mean by doing it just on the graph. They're 2 away from the vertex. And since this graph opens up, we have a minimum of 1. Our domain is all real numbers. Our range is greater than or equal to 1. Now this graph is decreasing to the left. Of 3, that's my x value, and then that makes it increasing to the right of 3. Here on this side, it's going up. Number 13 says solve the system of equations by graphing, which means we're going to graph both equations on the same coordinate plane and find where they cross. So my first equation is in vertex form. -1, -2 is my vertex. I'll make a table. I'll put 0 and 1 in there, -2 and -3. Plug in 1, 1/2 times 1 plus 1 squared minus 2 is 1/2 of 2 squared minus 2, half of 4 minus 2, 2 minus 2 is 0. Plug in 0. 0 plus 1 squared minus 2. 1/2 of 1 squared minus 2. 1/2 minus 2 is negative 1.5. So let's graph this. We have -1, -2, 0, -1.5, 0, 1. So then that's going to reflect to -2, -1.5, and -3, 0. And we're going to draw that nice and big. Then we'll draw our x, our other equation. Do that in blue. Y equals -x squared plus 4x plus 3. So x equals -4 divided by 2 times -1, which is -4 divided by -2, 2. Plug that in to my table. +2, 1, 0. Well, I know that when I plug in 0, I get the y-intercept, 3. It goes with the y-intercept, not the vertex. I have to plug in 2 to get the vertex. So -2 squared plus 4 times 2 plus 3. That's -4 plus 8 plus 3. And -4 plus 8 is 4. 4 plus 3 is 7. And then let's plug in 1. -1 squared plus 4 times 1 plus 3. That's -1 plus 4 plus 3. 3 plus 3 equals 6. And then I could do 3 and 4. I get 6 and 3. Then I'm going to graph it. Graph this table 2, 7. And then 1, 6. 0, 3. And then those reflect. And this point reflects. And so it looks like here -1, 2. And actually, it's kind of looks in between here, but when I graph this more accurately, I see a point at 3, 6. So if you're actually, the problem is asking for the solution, we want to graph it real accurately and plug in a point in that area to see if they have the same y value. All right, number 14, the path of a frog jumping from a tree branch to a pond can be modeled by the function h of x equals -0.5x squared plus x plus 7, where x is the horizontal distance. And it said the height. So h of x is the height. And they're both in centimeters. From the end of a tree branch and represents the height the frog is from the pond. So we have a little pond here. What is the height the tree branch is from the pond? Well, our y-intercept always tells us it's our starting point. So that means this tree branch is 7 centimeters above the pond, because that's our y-intercept. What is the height of the frog from the pond if he is 2 centimeters from where he started? So I want to know on my graph, what's the height at 2? So I want to plug in 2 for B. -0.5 times 2 squared plus 2 plus 7. Remember to do your exponent first. And that's -2 plus 2 plus 7 equals 7. So he's also 7 centimeters above the pond when he's 2 centimeters away. How far will the frog be from the tree? Well, I can see from the way this is drawn that 2 centimeters is after the vertex because he was going up first. A jump always increases first and then decreases. So I need to use some guess and check. Okay, so our equation, negative 0.5 times 3 squared plus 3 plus 7 gives us 5.5. So he's still above the pond. Being at the pond, we would get a 0. So with this calculator, I can just hit second enter and I can change to a 4. We can also push the up arrow on our TI little blue calculators and get that. So at 4 centimeters, he's 3 centimeters high. Still not on the ground. We're looking to get 0. What about 5? Now my answer is negative. So if my answer goes from a positive to a negative, that means somewhere in between 4 and 5 centimeters, he hit the water, because under the water would be negative. That glare. So now let's try 4.5. It's positive, so we're going to try 4.6. Positive still. What about 8? Let's skip one and see if we can get closer. Okay, we're getting closer. 0.28, 4.9. Now it's negative. So that means in between 4.8 and 4.9, he hit the water. So we're going to go back and we're going to insert 8, 5. See if we can get closer. That's pretty close to 0. Let's try 8, 6. Getting there. 0.05, 8, 7, 8, 7, 0.01, 4.88. Let's see. And it's negative again. So we can safely say between 4.87 and 4.88, that's pretty close to 0. If I want to keep getting more accurate, I just keep adding decimal places. 8, 7, insert my 5. Let's just do this last one. See what we get. That one's negative. I can't leave it alone. Got to get closer. Change that to a 4. Oops, I forgot to change that second 4. That's pretty close. We're almost to 0. Okay, so that's 0.0000. There's 4 zeros in front of that 6. I think it's safe to say 4.873 or 4.872 is going to give us pretty close. I mean, that's 3 decimal places. So for C, that's how we're getting our answer. 4.873 centimeters. That gave us 0.00005 negative. That's pretty close to 0. So this is 4.873. The next thing it asks us is how far from the tree branch will the frog be when it reaches its maximum? That's asking us what is the x value when he reaches this maximum. So that's our vertex. That's our x equals negative b over 2a. Negative 1 divided by 2 times negative 0.5 is negative 1 divided by negative 1, positive 1. So the answer is 1 centimeter. 1 centimeter from the tree branch, he reaches his max height. What is the maximum height reached? We have to plug that in. Negative 0.5 times 1 squared plus 1 plus 7. Negative 0.5 plus 1 plus 7.5 plus 7 is 7.5 centimeters. So his maximum height is 7.5 centimeters. And when is the frog ascending? Well, he's going up first. All right, so he's going up first from 0 to 1 centimeter. So F, he's ascending between 0 and 1 centimeter. And he's descending from 1 centimeter to where he lands at 4.873 centimeters. And then describe your domain and range. Well, my domain is from 0 to where he lands, 4.873. And my range is from 0, the ground, to his maximum, 7.5.